So here's that real life example that I talked about. A banquet hall has small square tables that seat one person on each side. The tables can be pushed together to form longer tables. So around one table we have 1, 2, 3, 4 people. Around two tables we have 6. Around 3 tables we have 8. And the pattern continues. Patterns are all around us. Oh boy. Sketch the next 2 table arrangements in the pattern. Well, I see 1, 2, 3 tables. Now let's do 4. And now I'm not going to be as beautiful as the textbook that I took this picture from. I'm going to say, okay, here are my people, here are my tables. And I'm going to say 4 tables. And we have 4 10 people. And with this one, we have 5 tables, but we have 5 tables, and we have 12 people. Now, this is a little bit more abstract. What stays the same? What changes? Well, what I would say is what stays the same, that's the 2 end people. So the 2 people at the end, there's always going to be just 2 people at the end, no matter how many tables you have. But what changes is the number of people between the 2 ends. So changes between the 2 ends. So let's set up this table here. We need our dependent and our independent. So at the end of the day, we want to know how many people are around the table. So that is going to be our dependent. So I'm going to say P, and P equals number of people. And we're going to call this T, and T equals number, not hashtag. I don't want to hear that. Number of tables. And we're going to set this up. Now we're going to leave the 0th, okay, 0th table. Remember, that's just our constant, so that's what stays the same. So the thing that stays the same is the 2 end people. So I can just put that in right away. Sometimes it's easier for us to fill this in initially, and sometimes it's easier for us to just like record the data first and then go back to it. So the way that we get to the 0th term or the 0th figure will change depending on what information we have. So at one table we have 4 people. At 2 tables we have 6 people, and so on and so forth. The 3 tables we have 8. 4 tables we have 10. 5 tables we have 12, and you guess at 6 tables we have 14. So basically what we're doing is we're saying the table number, so number of tables times 2, because 2 people are added actually every single time, so we go from 4 till 6, plus the 2 end people. Now I've started hinting at an equation. This right here, this system will help us. 2 end people equal total number of people. This is going to help us answer these questions. So at 6 tables, well, we got that in our chart there, 14 people. At 10 tables, so we say the number of tables times 2 plus the 2 end people. So 10 times 2 plus 2, remember BEDMAS, can never forget that. 10 times 2 is 20 plus 2 is 22. What about at 25? 25 times 2 plus the 2 end people. So 25 times 2 plus the 2 end people. 50 is 25 times 2 plus 2 is 52. So what I'm going to give you more practice in is creating charts of data based on specific situations. And then I'm also going to ask you what stays the same, what changes, and then I'm going to ask you at different, using what you know of the pattern, or using a little bit of knowledge of equations, you can figure out what the dependent variable is. Before I turn this off, I'm going to make sure that we write here that this is independent. Indep and dep, so independent and dependent. That means that I can take the number of tables and I can put it through our system and come out with the number of people.